Hello, everybody. It's been a while. Welcome to the homework helper for section 5.5. This one is a fun one. It's 12 simple problems where we're going to be doing a lot of graphing and shading and that sort of fun stuff. So let's go ahead and get started here. I'll start with number one here. We're going to be graphing two variable inequalities. So it gives us the equation, it gives us the graph, and it says for each inequality and graph, pick a point. Pick a point. We get to choose a point and use it to determine which half plane, so half plane, either this side of the line or this side of the line, that's what the half plane means, should be shaded, then shade the correct half plane. So what I'm going to do is I'm going to pick a point. I'm going to pick this point. How did I pick that point? I threw my pen at random. But what point did I pick? Well, it turns out I picked the point 3, 3. Cool, 3, 3. So now I'm going to see if 3, 3 satisfies the requirements of y is less than 1/5 x minus 4. I'm going to do that by plugging in my x and my y. So my y value is 3, and that's supposed to be less than or equal to 1/5 of my x value, which is also 3, minus 4. So I get 3 is less than or equal to 3/5 minus 4. And then that's going to be 3 is less than or equal to, well, 3/5 is going to be less than 1. So what does that turn out to? Well, I need to get this into fifths. To get this into fifths, I multiply it by 5 over 5. So that's 3/5 minus 4 times 5 is 20. 1 times 5 is 5. Okay. So 3 is less than 3 minus 20 is a negative 17/5. So is 3 a smaller number than negative 17/5? No way. Negative 17/5 is negative. 3 is positive. That's an easy way of doing it. And so I know that this does not satisfy this equation, right? This is not true. Not true. So therefore, I have to shade the other side. I have to shade the other side of the point. And that's how we do. You just pick a point, see if it works. If it did work, if that did make it true, I would shade that side. But if it doesn't work, you shade the opposite side. You shade the other half plane. All right, let's go to the next ones. All right, this one's cool. So for this time, what we're doing is we're working backwards, is we're going to be looking at the graph, use the graph, and we're going to write the inequality. So it's just seeing what it is and turning it into a y equals mx plus b, except we're using an inequality sign. So let's think about y equal, whoops, helps if I have it on the screen, y equals mx plus b. So the first thing I want to do is I want to find my b, which is my y-intercept. So I see where it crosses the y-axis, which is right here. So this is my b. And this is 1, 2, 3, 4, 5, 6, 7. So my b is 7. So now I need to find my m, which is my slope. So whenever I find my slope, I'm looking for my rise over run. And when I look for my rise over run, I look for 2 points that satisfy it completely. So you see that right here it hits it, it crosses right in the crosshairs. Well, it does right here too. Okay, cool. So now I just need to find the rise from here to here. The rise is I go down 1. So my rise is negative 1. And my run is I go up 1. So my m is negative 1. So now I have my m, I have my b. I can write most of my inequality. I can say y equals negative 1m, or just negative, oh, I'm sorry. What am I thinking? Y equals negative 1x, or negative x, plus my b, which is 7, except it's not an equal sign, right? This is an inequality. And so when I look at this, I have to figure out what side of the equation this is working for. What side of the equation is it working for? And I see that at my y-intercept, all the numbers below my y-intercept are shaded. So that tells me that y is less than or equal to negative x plus 7. And the or equal to is because it's a solid line. A solid line tells me that it's going to be or equal to. Let's look at some of these other ones. See, for this one, here's the y-intercept. I'm not going to do all the problem. I'm just going to figure out what my sign is. It's going to be y is, well, now it's shaded above that, so it's going to be greater than. And it's a dashed line, so that means I'm not going to write the or equals to. It's just going to be y is greater than whatever our mx plus b is. Okay. Let's look at this one. Okay. So this is going to be y is, well, here's our intercept, and all the numbers below it are shaded, so that means y is less than. And then because it's a dashed line, I leave it as less than mx plus b, and then you can find the m and the b. And then finally this one here, y is, well, here's my intercept and it's shaded above, so y is greater than but it's a solid line or equal to. And then you can find the mx plus b. You can find the slope and the intercept from there. Okay? So those are your hints on how to do those. Finally, let me get this in the screen. For each proportional relationship below, one representation is provided. Create the remaining representations and explain any connections you notice between the representations. So here is my thing. So I have day one. So it starts with a table. From a table, it's really easy to make a graph. So I know this is the table. So at 1, you're at 8. Oh, look at this. Look at this. It goes up. It goes up by 8. So I gotta go all the way to 32 by 4. That's a lot. So I'm gonna make these be 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, so let's see what happens. So at 1, 2, 3, 4. At 1, I'm at 8. At 2, I'm at 16. At 3, I'm at 24. At 4, I'm at 32. And then, at 5, I know I'm going to be at 40. Okay, at 5, I know I'm going to be at 40. So I know that this is going to be my line. It's going to look something like this. Okay? I see that that's happening. If I were to write an equation now, I know that, well, it looks like 0. So y equals, my b, it would cross right here at 0. So I know it's going to be a plus 0. What's my slope? Well, every time I rise 8 and run 1, so it's going to be y equals 8x. That's my equation. Okay. And then finally it asks for a context. I don't know. Cost is 8. How much Victor spends on burritos. I do like a burritos for lunch per day, or something like that, something simple like that. And that's it. So just taking one piece, we got to work in between. This is the making connections in mathematical representation set of our mathematical brain. And that's it, guys. And that's it. It's only going to be 12 questions. Pretty simple. You should be able to knock this out for homework, no problem. And then we'll come back tomorrow and keep moving forward. Thanks a lot. Have a good one.